Good morning, all. Am I audible, man?
Good morning, sir. Yes, sir, you're audible.
Right. We're discussing Newton's laws. Let us continue our discussion. See, the summary of what all we learned is there are many types of forces. The real forces are forces that have an origin. That means the cause is known. Okay. So here, net force. Okay. Net force acting on a particle with respect to observer who is not accelerating. Is nothing but mass of particle into acceleration of particle, remember, with respect to observer A. Understood this? Clear enough?
Yes, sir.
Is it clear?
Yes,
Right.
sir.
Now suppose we have another observer. This is nothing but plus what you will have. Into what you will have here.
Minus acceleration of particle. Acceleration of observer B. Minus acceleration of observer B with respect to current.
Understood this? Clear? Now we call this. Understood not? No.
Yes, sir.
Shall I turn the page? We discussed about acceleration frame, no? Reference frames. Inertial frame already we finish it now.
Yes, sir.
Shall I turn this?
Yes, sir. 1 minute, sir. 1 minute, sir. 1 minute. Sir, 1 minute.
This is only called pseudo force, no? This
Yes,
whole
sir.
thing is
Yes, sir.
called what? Pseudo force. Finished? Completed?
Yes, sir.
Completed, sir. Completed, sir.
So, suppose, as we discussed, this is a trust. This is observer A. This is observer B. This is observer C. Okay. Now this observer C is accelerating. Velocity is not constant. This velocity is constant. This velocity is 0. Okay, now you can see that suppose here force on M into acceleration of M with respect to whom? A. Is seeing that. Followed this or not?
Follow,
Clear?
sir. Clear, sir.
Next. Force on M with respect to B. See here, this is mass M with respect to ground, B with respect to ground, because this is a thrust with respect to ground. So obviously, mass is not accelerating, B is also not accelerating. So this will be 0. Do you agree with this?
Yes, sir.
Agree,
Now
sir.
you can see mass M with respect to C acceleration. Mass into acceleration of M with respect to C. This is mass acceleration of M with respect to ground minus acceleration of C with respect to ground. This is nothing but rest. This is nothing but Sangya. Do you agree with this?
Yes, sir.
That means a body can be at rest with respect to ground, provided the observer is having a rest or moves with constant velocity. Understood this?
Yes, sir.
So a reference frame in which a free particle means that force is 0, is at rest with respect to a frame, then we call it as inertial reference frame. Any doubt in this?
No, sir, no doubt.
Yeah.
It may be at rest or it may be in uniform motion also. Then also acceleration won't be there, no?
Yes, sir.
Understood this?
Understood, sir.
Yes, sir.
Clear?
Yes, sir.
Shall I turn the page?
1 minute.
Sir.
Before tomorrow's exam, we have a little bit of projectiles, little bit of kinematics, little bit of relative velocity. Just all concepts just refer and write, nothing will happen. If you get less marks also, no problem. Shall I turn this?
Yes, sir, completed.
Just a second, please. Just a second.
Complete? Finished?
Yes, sir, completed.
Right. So here we can say a reference frame in which is in its state of rest or of uniform motion. In a straight line. Are defined as what?
Inertial reference frame.
Understood this?
Yes, sir.
Similarly, frames of observer A and B are inertial. Agreed?
Yes, sir.
On the other hand, a reference frame in which A free particle does not are what? Non
Inertial.
in the above example. Frame of observer C is what? Till here, any doubt?
No, sir.
Right. So just to check that the frame has acceleration with the with respect to ground. Definitely it is a non-inertial frame. Can I turn this?
Yeah.
1 minute.
Now, can Earth be considered as an accelerating frame or an inertial frame or non-inertial frame? Earth.
Non-inertial.
Earth is non-inertial or inertial.
Non-inertial.
Non-inertial.
Why?
So because
Because it rotates constantly.
Even strictly speaking, Earth is
Sir,
also
inertial,
non.
sir. Inertial.
No. Earth
Inertial
is
frame, sir.
no. Earth is also non-inertial. Understood this?
Sir,
See,
it
for
moves with
example,
constant velocity, na, sir. Earth.
why man? This is
Yes,
Earth,
sir.
na?
In a day, it completes one rotation. In 365 days, it completes one revolution, na, sir.
Yes, man.
So it is fixed, na, sir. It moves
Constant
constantly.
velocity doesn't mean acceleration is constant, no. There is a centripetal force, no. AR is there or not?
Yes,
AT may be,
Yes,
AT
sir.
is zero. So Earth is accelerating or not?
Yes, sir.
Accelerating, sir.
Yes,
Okay.
sir.
Okay. Then how you can consider as inertial frame means, however, a frame of reference, a frame of reference may be considered, okay, as inertial if its acceleration is negligible. Understood this?
Understood, sir.
As Earth's acceleration is almost negligible, we can take Earth as a inertial reference frame. Understood this?
Yes, sir.
To measure, shall I turn this?
1 minute, sir.
Finished?
Done, sir.
1 minute, sir.
Over?
1 minute, sir.
Shall I turn this page?
Sir, why is tangential acceleration 0, sir, for Earth?
It is moving with constant velocity only, no? Linear velocity is not changing. No? You're having 1 year now for revolution. It is
Yes, sir.
changing.
No, sir.
Then
Sir, this last point, the frame of reference may be considered as inertial if its acceleration. Sir, here
regulation.
is negligible with respect to the acceleration of object. Sir, whose acceleration is negligible? Is the acceleration of observer is negligible, or
No,
the
no. If it's I wrote this here, no, it's as a frame of reference as inertial if its acceleration means the acceleration of the frame is negligible considered action. For example, shall I turn this? I'll explain.
yes,
Yes,
sir.
sir.
Usually the last lines I have to explain. This is Earth. This is some apple. Okay. Now you know by Newton's law, this is subject to a force of gravity. Remember,
Yes, sir. Yes, sir.
this is also subjected
Yes,
to same force, no?
Yes, sir. Normal force.
Huh? Force of
Intermolecular.
gravity.
Force.
Gm by separation between them. Newton's law of gravitation, remember that?
Yes, sir.
This is also same force, no? Remember this, two particles, two
Yes,
objects are
sir.
separate, that's gravitational force. Now you can see on both, what is the acceleration of apple? Force on apple by mass of apple. Now acceleration of earth, force on earth by mass of earth. Now you can see that as force on earth and apple. Okay, understood this?
Yes,
And the
sir.
mass of apple is very small compared to which acceleration is more?
Acceleration of Earth.
Sir.
Do you agree with this?
Yes, sir.
Yes, sir. Agree.
Okay. So we can say to mesh to we can consider Earth as what? Inertial frame. That's what I wrote the last statement. Now you followed? Some boy asked out now. Is it clear?
Yes, sir.
Clear, clear.
So mostly the acceleration of Earth is negligible for the event. Car is moving with acceleration. You won't see Earth is having acceleration. We don't find that now. Understood this?
Yes, sir.
Yes, sir.
Shall I turn this?
1 minute, sir. 1 minute, sir.
Now let us go ahead with Newton's laws of motion. Shall I turn this?
1 minute. Sir,
Till.
sir, I didn't understand the statement you wrote now, sir. As force of Earth and Apple have same magnitude. How they have same magnitude?
What is this
Which
you wrote?
magnitude?
What are these called?
Sir, Earth possesses the gravity now, sir.
This is the force, man, force of gravity between two particles. You know
Yes,
Newton's law
sir.
on gravitational law. What does it say? Whenever two particles are separated by a distance r, each particle is subjected to a force of attraction. No? What is
Yes,
this
sir.
force?
GMM square.
That's all. Earth won't possess any force. Every particle is attracted by other particles by this law. Understood this?
Yes, sir. Yes, sir.
This is on. That's why we call it as universal law of gravitation. The meaning of that is there is no other law saying using the word universal. Only two things you will come across. Universal gas constant, meaning the value remains same for all gases. Remember that? Similarly, universal
Yes,
law of
sir.
gravitation means this law is applicable for all masses in all that in any medium. So here this is attracted by this force, this is attracted. They are having same magnitude, no? Am I right or not?
Yes, sir.
Yes, sir.
Clear? So this is the force of gravity. Similarly, this is the force of gravity. Is it clear?
Yes, sir.
Why we find Earth, we never observe Earth to be accelerating is very small. Clear? Negligible acceleration it has.
Yes, sir. Clear.
Shall I turn this?
Yes, sir.
Yes, sir.
the absence of external forces, when viewed from an inertial frame, an object at rest remains at rest. Okay, an object in motion. Continues understood this?
Yes, sir.
Clear? So turn the page.
Yes, sir.
Shall I turn this?
Yes,
Yes,
sir.
sir, completed.
1 minute, sir. 1 minute. Done, sir.
Finished?
Yes, sir.
So from this law, if you observe carefully, your body by itself cannot, what will happen?
Accelerate.
A cannot, first one, cannot set into motion
without
if
an
it
external
is
force.
at rest.
Rest.
Cannot come to rest if it is in motion. Agreed? Cannot change
Speed and direction of motion.
its direction of motion. Cannot okay, that means body by itself cannot do any of these things. In English, what do you do? What do we call that? Anything you cannot do by itself. What is that? Inertia. What is called? Inertia. Okay. So, understood this? So, this is what we call it as inertia, inability. We name it as inertia of rest. And we call this as inability to change direction. What is that? Inertia of direction. Do you agree with this?
Yes, sir.
Yes, sir. Inertia of
This
acceleration.
is, followed this? So this is nothing but inertia of motion. Understood this? Clear?
Yes, sir.
Clear, sir.
Shall I turn this? Complete this?
Yes, sir, completed.
1 minute, sir.
No. You have seen that in the beginning of Newton's laws statement. What is the first line of first law? Can you tell? In and what? Read that.
In absence of external forces.
No. Starting line. Here. When viewed from which frame?
Inertial frames.
So remember that Newton's laws are applicable only in which frames?
Inertial frames.
Inertial frames. Okay. So remember that as the main thing. Newton's laws of motion. Are applicable applicable only in what?
Inertial frames.
Clear?
The spelling of it.
Not clear.
Yes, sir.
Yes, sir.
One
The
second.
camera.
Zoom. Now?
No clear,
Not
sir.
clear, sir.
Correct. Complete there?
Yes, sir.
So here we can say neither first law nor second law but still we want to apply.
Sir, in non-inertial frame, no, sir. Valid in remains valid in non.
No, inertial frame, no? Applicable only in.
Okay, sir. Sir, I saw neither first law. That's it, sir. I asked.
Now it is correct or no?
Sir, actually,
Hmm. What you should do? See, suppose you like one very nice shirt in a showroom. You want to have, but that size is more, it is having larger size than what you require. But still you like, what you'll do? Jeans or anything, you purchase that and give it to fit into your size, not to trim it to your size or not.
Sir.
Okay,
yes, sir.
so like that only you want to still apply. And what you have to do? We are allowed to do so, provided
Sir, you wrote that Newton's laws of motion are applicable only in inertial frames.
yes.
Yes, sir. Then you wrote neither
Then you wrote neither first
remains
law nor
valid.
second law remains valid in inertial frame.
Hmm?
Sir, in the below point of that, sir, are applicable only in inertial frames. You wrote
This
neither
one,
first law nor
okay,
second law.
okay. This is what he told us. Right, this is what Jasin told, I think. Right, now it is correct or no? To do
Yes, sir.
so, provided, what we should do? We include what? An additional force. Remember? What is that additional force? Called, one force is there. Pseudo force. Remember?
Yes, sir.
Equal to minus of Remember, all this we have finished.
Yes, sir.
In the free body diagram, means the diagram showing forces on a body. Understood this? Strictly speaking, Newton's laws are not applicable in non-inertial frames. But still, if we want to apply them, we can do so by considering the pseudo force. Understood this?
Yes, sir.
Yes, sir.
Shall I turn this?
Yes, sir.
Any doubt is that till here?
1 minute. Sir.
1 minute,
Yes,
sir.
Shall I turn this?
Yes, sir.
Yes, sir.
1 minute, 1 minute. Done, sir.
Now, we have come across something called as linear momentum. It is a physical quantity which is nothing but what? Product of
Mass and velocity.
See, for example, you have P bar, we generally use this. Clear?
Yes, sir.
Now you
Yes,
can
sir.
see whenever two vectors are there, direction of V bar is same as P bar, no? Agreed on it? So direction of V bar any doubt is there till here?
No doubt, sir.
Next. See, actually, Newton's first law simply says what a force does. Okay, that means this is nothing but it describes what the qualities of force. That means force can increase speed, force can decrease speed, force can change direction of motion, all those things now.
Yes, sir.
Correct. So first law is called, first law is qualitative definition of force. Okay. Now how to measure? That is quantitative. See, for example, when you go to a showroom, you see a shirt or the trouser. You'll say it's very good, color is good, design is very good. Okay, outfit is very good. Overall, you'll feel all that, describe that. Okay, or color is bad, something. The last next thing, what you have to do? What is the price of that? You'll ask or not? Do you
Yes,
agree
sir.
with this? So that is only quantitative definition of force. Okay, this is discussed is understood this clear?
Clear, sir.
Clear, sir.
Return this.
1 minute, sir.
ఇది చేయమా? నేను లేదు.
Done, sir.
Finish this.
Yes, sir.
Yes, sir. 1 minute, sir. 1 minute.
One more.
One sec.
Finish. 1 second. 1 second. So we'll Newton's second law states that why we are actually applying force first thing? Basically, we want to change the state of rest or motion. No? That means we want to change velocity. No?
Yes,
Okay.
sir.
So it says that
Sir, your camera is not clear, sir.
etc.
Yes, sir. Now it is clear.
Yes, sir.
So here rate of change of linear momentum of a body is directly proportional to the external force applied takes place in the direction of force applied. No,
Yes, sir.
that means mathematically external force acting on a system is equal to that is nothing but d by dt of v. D by dt of, we agree with this? Any doubt is there?
Sir.
See, first I thought calculus d by dt and all. At that time, you felt about what is all this. Without this, you cannot teach anything in physics. The problem is that. So even though it is difficult, I have to teach. If I ignore this, definitely your result will be horrible, which I don't want. To make you happy, I can ignore many things. But here I am not there to make you happy, no? Now, this is, mass is variable or change, constant?
Constant.
No, there is no
Mass is
doubt.
constant, sir.
No, mass will change. Then it may change. That means even mass may change. I'll tell, for example. See, just note down, I'll tell. See, for example, there is a cart like this. This cart is having sand on this. Now there is a hole here. Then what happens? Sand is falling now.
Sir.
Yes, sir.
Yes, sir.
Then what happens? It's a variable mass only now.
Yes, sir.
Yes, sir.
Yes, sir.
Now, for example, this is some snow. Now, as it falls, what will happen? It will gather some mass or not?
Yes, sir.
Yes, sir.
Yes, sir.
All these are nothing but variable masses, no? All these are
Yes.
variable mass only.
Sir.
These are variable mass systems. For example, a chain is there, a rope is there. Now, initially only this part is there. Slowly, what happened? The amount of mass on the ground is changing now, or hanging mass is changing or not?
Yes, sir.
Yes, sir.
So remember that mass need not be constant. So see how many things you have to learn in physics. Generally, people say mass is constant. There is no chance that mass should be. Suppose a rocket is moving up, it consumes fuel. Is mass constant? A bus is
No, sir.
moving. When it starts, it has 100 liters of petrol. As it travels, the petrol is consumed. No, is the mass remaining constant?
No, sir.
Hmm. If mass remains constant, definitely you and me need not do any physical exercise only. No, why should we do? No gyms, nothing is needed. Anything you can eat and maintain the same mass. It's a wrong perception and conception that mass remains constant. Okay. Now, that's why remember that external force. What is this force? External force acting on a system is this. Understood this?
Yes, sir.
If under the condition mass remains constant, that's why we first study mass remaining constant, then we go to variable mass systems. Then what you have? dm by dt is 0. In such case, what you have? F external is what? M dv by dt. So me. Understood this? Clear?
Clear,
Yes,
sir.
sir.
So F is equal to ma is valid only if the mass is constant. That means constant mass systems. It is not applicable for variable mass systems. This is for variable mass. This is for constant mass. Is it clear or not?
Yes, sir.
Yes, sir.
Anyhow, for tomorrow's exam, you don't have all this. You don't worry about this. Now I'll make you do some problems on slowly you'll pick up. So far, I'm just explaining what are Newton's laws and all, no? So don't get worried much.
Completed, sir.
What are they?
Yes, sir.
So you cannot accept when I teach something because you learn something different from what you are learning now, no? There is a problem. F external is this is for what?
Variable mass.
Okay. Understood this?
Understood, sir.
Any doubts are there in today's class?
No, sir. No
No,
doubts.
sir. No, sir. Sir, in the Manas exam, there is only circular motion and projectiles.
That's it. Okay. Right then. We'll meet in the next class, okay? Till here, any doubts are there?
No doubt, sir.
No, sir.
Don't worry about Newton's laws. I'll do make you do some problem. You'll feel confident, okay? Take care then. Bye.
Thank you, sir. Bye, sir.
Bye.
Bye, sir.